Okay, for this station, I'm going to have you copy all of this work onto the handouts I give you, and then I need you to document those with either your phone or using the Chromebook itself. Alright, so here we go. So for these, again, I need you to know how to fill out a table when I don't give you numbers right next to each other. I need you to be able to find how much you're increasing from one to the other given these two numbers. So the first thing I need you to do is see that you're going up by 5, and on the bottom you're also going up by 5. So if I compare that change from here to here, here to here, if I divide that out, what that does is give me the common difference, or how much I'm going up by now going up by one term. But again, from here, from 4 to 9, going up by 5. 2 to 7th term, going up by 5. That change, 5 over 5, gives me 1. That is my common difference. That number is the number that will go in front of x. That is the number that I'm increasing by each time when I'm going up by 1 in the sequence. So this equation is f of x equals 1x, and then I could use that common difference number to backtrack to the 0 term to find that y-intercept number. So going up by 1, going up by 1, going up by 1, going up by 1. To the left, the opposite, minus 1, minus 1, minus 1. Excuse me. This gives me 4, 5, 6, 7, 8, and then backwards gives me 3, 2, and 1. And I can see 2 is my y-intercept. So this equation is f of x equals 1x plus 2. My second equation, my second table here, from 1 to 11, I'm going up by 10. And from 1 to 6, I'm going up by 5. So to find the rate of change for this sequence, or this function, or this pattern, I divide 10 by 5, and that gives me 2. That's my common difference. That's the number that's going to go in front of x. That's how much I'm going up by when I'm increasing by 1. So f of x equals 2 in front of the x, plus, and then finding that y-intercept number, again going up by 2's now. When I'm skipping ahead, I'm going up by 10, but now one at a time going up by 2. So this will be 1, 3, going down by 2 to the left, gives me 3, 5, 7, 9, 11, 13. Going down by 1 gives me negative 1, negative 3. That y-intercept is negative 1, so this is f of x equals 2x minus 1. I need you to see that the point they share in common is 5, 3. For this problem, I'm also going to have you plug that in and check. But what I also want you to see is these are coordinates. This coordinate 5, 3, 5 will satisfy both these equations if I plug in 5 for f of x and 3 for x. I'm going to have you do that on this paper. But first, I think I'm going to graph this. I want you to see that graphing these are coordinates. I need you to see that. A table or a function gives you coordinates to plot. So get on your paper, I want you to plot these coordinates. Again, this is a mistake right here. Don't plot that one. But my points are negative 1 for x, up 1 for y, or kind of negative 1, up 1 for f of x used to be y. That's this coordinate right here. Left 1, up 1. The next point, 0, 2, is this one right here. Over 0, up 2. The next point, 1 for x, 3 for y technically. Over 1, up 3. Next one, over 2, up 4. Know that these coordinates come from this table and we'll give you a nice straight line because it's going up by 1 each time. And then I also need you to see that this is slope-intercept form. There is my y-intercept, 2. From there, I'm using my slope, 1 over 1. I'm going over 1, up 1, or up 1 over 1, up 1 over 1. That matches this rate of change, 1, which matches this. That's my slope. That's my rate of change. That's my d. Up 1 over 1, up 1 over 1. There's my y-intercept, 2. The next line, which will be this one. And then please, I need you on this graph to label this. This is f of x equals 1x plus 2. Label that, please. The next line, this f of x equals 2x minus 1, is going to come from these coordinates. So -1, -3 for y. -1 for x, down 3. That's this point right here. Down 1, down 3 boxes. Left 1, down 3 boxes. The next point, 0 for x, down 1. Next, over 1, up 1. Over 2, up 3. Again, getting those from these coordinates. Over 3, up 5. Over 4, up 7. Keep going. Over 5, up 9. Over 6, up 11 if it fits. Keep going. I'm going to draw my line. I'd like you to graph this best you can on this paper. And again, notice that this follows slope-intercept form. -1 is my y-intercept right there. My slope, 2 over 1, over 1 up 2, over 1 up 2 matches this rate of change made into a fraction, 2 over 1, rise over run, over 1 up 2. What I'd like you to do on your paper is do all this work, show all of this, but what I'd also like you to do is now show this check. I would like you to take this point 3, 5 and check it into both these functions right here. So when you're doing your check on this paper, again, full credit for this station, document all of this work right here and then show me the check on your paper. And again, when you're doing the check, you're plugging in 5 for f of x into both of these. And then 3 goes right in here for x into both of these. So you'll get 5 equals 1 times 3 plus 2. That will work. This one you'll get 5 equals 2 times 3 minus 1. That will work. So again, to get full credit, to document this, show all of this with the graph and that point right here labeled, indicating to me that you see those points, or that point right there is where they come together. And then do the check. Maybe down here in the corner of your paper you could check that problem. Alright, good luck. Document that with your document camera or your own camera.